Welcome. Okay, this is going to be a couple of lessons. We'll break it up, but in reality, this is about 3 lessons where we're going to be using work done, the gravity equation, and finding out about kinetic energy. First of all, have a look at the starter, quick answers. You should know these, and pause the video. And let's re-go. Right, here we go. Here are the answers. If you don't know it by now, energy, joules, and so on and so forth. No tricky ones there. Here we go. What work? Remember, work done is transfer of energy. So brakes transfer kinetic energy into heat. That's how they work, and via the process of friction. Okay, and let's move on. So what we want to be able to do in a few lessons' time is to answer formula questions, setting them out properly, neatly and logically. That's really important. Changing the subject of a formula, so rearranging formula, stating and use the formula for kinetic energy. That won't be in this video, it'll be in a future one. And ultimately, what we want to be able to do is solve problems that involve 3 formulas, these 3: work done, kinetic energy, and gravitational energy. Okay, so that's what we're working towards, more complex sort of problems. Moving on, here we go. Here's a little starter, a big picture starter. What energy transfers are taking place? Have a think. I'll tell you. Here we go. If we look at the guy there on the bike, we know we've got chemical energy is being transferred into kinetic, chemical energy in the muscles, into kinetic of the legs and the bike and so on. Gravitational energy gets turned into kinetic in a roller coaster. This truck here is lifting a box, so it's turning some sort of kinetic energy into GPE, into height, into gravitational energy. The one at the bottom are both examples of nuclear energy. The one on the left is nuclear fission. That's a bomb going off. That's a man-made nuclear bomb, human-made nuclear bomb. On the right there is the sun, which creates, or generates rather, energy through nuclear fusion, which is a different process. We'll learn about that later though. Okay. So just recapping, this is what you know from the lesson we did on work done, and there is another streams out there on this explaining it. And that is our formula there that we need to be able to use, which is the work done equals force times distance. And there are 2 examples there. Pause the video and refresh yourself of this, because we did this a few lessons ago. And this is the gravitational one, okay? A few lessons ago we looked at gravitational energy. It's mass times the gravitational field strength, which on Earth is approximately 10 newtons for every kilogram. That tells you how strong gravity is. And we multiply by height, okay? And there's a little example there of using that formula, which is fairly simple. Once again, pause this video, refresh your brains about that, and then we'll move on, okay? So this is the task. A number of questions. First of all, to do numbers 1 through 5. Okay, solving these problems, and it's really important that when we solve problems with formula, we actually follow. On the left there, you can see this sequence of events. We write the formula, we rearrange it if necessary, we substitute, and we calculate the answer and add units. Don't miss any steps out. If you miss steps out, you'd be missing marks on the exam. And here's an example. The first one is done for you about Robert pushing a car. That's how you set it out. Okay, formula, put the numbers, and then calculate the answer. Now, on the subject of rearranging, let's just pop up this the camera here. Let's rearrange that first formula. So our first formula is work done is force times distance. Now, if I wanted to find the distance, which is S, remember, and I wanted to make that the subject, here we go. If I make that the subject, then S is equal to work done over force. If I wanted to find the force, because I knew the other 2 values, then force would equal work done divided by distance. Okay, they are our 3. Oh, here you go. This is the formula just rearranged in a couple of times. Okay, so without more ado, have a go at those questions. Let's minimize that. Have a go at those questions and pause the video. Okay, and we're back. Whoops. Let's make sure it's on. There we go. So moving on, there's our example. And these are our solutions. Okay. Notice how I followed the steps, particularly in 4 and 5, where I've written down the formula, then I've rearranged it, then I substituted the numbers, and then I've calculated the answer and added units. Okay, so your answer should look like that. If they're not set out like that, you're not doing it right. Follow this procedure. Okay, that is all for now, I believe. Oh no, that's not all for now. No, because we have, whoops, sorry about that. We have the gravitational equation questions to do. So following the same procedure, you will need to do that for the questions involving gravity. Before we do that though, let's have a look at rearranging the gravity equation. We know that gravitational potential, I'll just call that E, is mgh. Fairly simple. Mass, gravity, height. If I wanted to make m the subject, I need to divide both sides by gh, so I end up with this formula. If I want to make g the subject, I want to find the value for gravity, I end up dividing by m and h. And if I wanted to make h the subject, because I didn't know what h was, the height, it would be E over mg. Okay? Very simple rearranging. Now you should be doing this in maths. Essentially, to get m on its own, in this case, I divided that by gh, and I divided that by gh, and that cancel with that and that. You get the idea? Have a think about it if not, but these are your 3 rearrangements of that formula. So without further ado, you can have a go at those questions. Whoops. Have a go at the gravity questions, which are questions number 6 onwards. Okay, I don't know if you can see it on the screen, you might have a printout. Pause your video now. And now we're unpaused. Here are your answers. Now, any eagle-eyed students will notice an error in my solution for question number 11. Okay, answers on a postcard, please. But the rest of it's fairly simple. Notice how I always start with, say, for example, question 9. Start with the equation, rearrange it. Oh, number 9 is a bit weird because we're actually finding the weight, okay, which is mass times gravity. Number 10, we're finding the mass, so we write the formula, we rearrange it, okay, and likewise with 11 and 12. So have a go at them. Any problems, get me on Teams. Enjoy.